In this video, we will look at adding and subtracting polynomials. You will take notes in your booklet on page 3 and 4. Remember, you are to watch, to listen to, and to take notes. We are going to start by taking a look at an example using algebra tiles. So I want to do this so we have that representation. So remember, in our algebra tiles, we have here at the bottom, we have our units. So that's our 1, 2, 3, 4. And then the red represents negatives. We have our x's, positive and negative, and we have our x squared, positive and negative. We'll talk more about these in class, but that's the basic gist of what's going on here. Now, for addition, what we're going to do is represent each of our polynomials using our algebra tiles. So x squared, that's going to be the blue, minus 3x, plus 4. You're not taking notes at this point, you're just watching. And then we're going to add to that our second polynomial, 2x squared plus x, whoops, and then minus 1. So those are our polynomials there. Now, in algebra, we combine our like terms. It's very easy to see when we're doing our algebra tiles. What I'm going to do is put my x squareds together, my x's together, and then my constants together. Okay, so you can see here I've got 3x squares. Now, when you have positive and negative, remember that x plus a negative x is going to be 0. So these can get removed because that's 0. Same with your units here. Same with your 1s, your 1 and your negative 1. We can pair up our opposites and these can get removed. So what I have as my simplified answer is 3x squared minus 2x. I'm actually going to remove those. Hold on. Okay, all I did was remove the ones that I said could be removed because it was looking a little too busy. So we have 3x squared minus 2x, because it's two negatives, plus 3. Okay, now watch this. When I do my polynomials here, what I have, combining like terms, x squared plus 2x squared is 3x squared. Negative 3x plus x. Signs are different, so I subtract and keep the sign of the larger. See, there's my minus 2x. And then 4 minus 1 is 3. So my simplified expression here is 3x squared minus 2x plus 3. And all I did was combine my like terms. So let's take a look. Now we're going into our booklet. We're on page 3. And we're going to work through some examples. So you can add polynomials by combining like terms. Remember, like terms means same variables raised to the same exponent. We can only add or subtract things that are like terms. And our algebra tile shows us why. I can't add an x squared and an x because they're not the same. They're not the same. So I can't combine them. Okay? So when you are adding, and let's actually first emphasize how I know that I'm adding. I know I'm adding because that's an addition sign, right? So because that's an addition sign, I know I'm adding. And really, since there's nothing to distribute, I can just ignore my parentheses. There's just a 1 there, so there's not really anything to do. So I'm going to combine my like terms. 1x squared plus 2x squared is 3x squared. Negative 3x plus 1x, I think this is the example we just did, is negative 2x. And then 4 minus 1 is 3. So that's my simplified. Okay? Example 2. Again, I know I'm adding because there's an addition sign in the middle. Ready? So I have negative 2x to the 4th, and I was about to underline that, but I need to be careful because that is not an x to the 4th. They are not like terms. So that's my only negative, that's my only x to the 4th. Now I'm going to take them in order. I'm going to go to the next highest exponent first. So then I'm going to do my minus x squared, because that's my next lowest degree, my next lowest exponent. Then I've got negative 3x and a positive 12x. Signs are different, so I subtract. 12 minus 3 is 9. And keep the sign of the larger. And then last but not least is that plus 9. Okay, so I got a little messy with my work there. Maybe if I highlight it can help you a little bit. So I'm going to do that for those of you that might need it. This one has no like terms. This one I did second because it was the next highest degree. The negative 3x and the positive 12x were like terms. And then the plus 9 had no like term. Okay? All right. Moving along, let's take a look at the next example. These are really just combining like terms like we've been doing. So there's nothing fancy happening here. All right, so ready? First, 6x squared and 3x squared. Those are like terms, so I'm going to combine them. 6 plus 3 is 9, and then x squared. 17 plus 1 is 18. Okay. Let's do this. Let's have you pause. You're going to work example 4 and 5. We will check it together after the video. So you're going to pause, you're going to try 4 and 5, and then we will check them after the video. We are now going to move on to the next page. So if you need to work 4 and 5, hit pause first. Okay, so let's talk about subtracting. Here's the important thing to remember with subtracting. Subtraction really means to add the opposite. That's our definition of subtraction. So if we're using our algebra tiles, we're going to represent our first polynomial. So our first polynomial is x squared minus 3x plus 4. Okay? Now, I'm going to temporarily draw a little line here. And I'm going to do my second one. My second polynomial is 2x squared plus x minus 1. Here's the key though. I don't want to add them. I want to subtract them. So to subtract means to add the opposite. So where I have 2x squareds, I'm actually going to flip them and make them negative x squareds. Where I have the plus x, I'm going to flip it and make it minus x. And where I have the minus 1, I'm going to flip it and make it plus 1. So now it is addition because I flipped all my tiles so that I have the opposite. Okay? And then once again, I combine my like terms. So I put my x's together, I put my constants together, I put my x squareds together. Okay? Remember, you can remove the ones that are opposites. So x squared minus x squared plus a negative x squared, I can remove those and that is it. So what I get here is a negative x squared, 1, 2, 3, 4, minus 4x, and then 1, 2, 3, 4, 5, plus 5. Okay? Now I think we're going to look at this example as our example 1. Yep, that's our example 1. So we'll go through the algebraic way to do that. So now we're in our booklet on page 4 and we're going to do a couple of examples. Okay, so here we go. When we were doing algebra tiles, to add the opposite, what we did was we flipped the tiles for the second polynomial. We can't really do that with our symbolic representation here. So what we need to do is to distribute the negative. Oops, moving the wrong thing there. We need to distribute the negative, which means change the signs. Then we'll combine like terms. So in the addition, we just basically ignored the plus sign because it was distributing a 1, and that doesn't change anything. On this one, because it is a subtraction sign in the middle, we know we're subtracting, so we need to distribute that negative. Okay, so we need to distribute that negative. So here we go. All right, let me change back to my pen. So the first polynomial will stay the same. We didn't need to flip the first one. Here's where we need to add the opposite, which in algebraic terms means we're distributing the subtraction or distributing a negative 1. So negative 1 times 2x squared is negative 2x squared. Negative 1 times x is negative 1x. Negative 1 times a negative 1 is a positive 1. So you're just distributing there. Okay? Make sure to show me this step. We need to show this step because if you skip it, you're going to miss a sign. You're going to mess up, so you need to show me this step. All right, now we combine like terms. So we have x squared and negative 2x squared. Signs are different, so I subtract and keep the sign of the larger. And then negative 3x minus 1x, signs are the same, so I add and keep the sign. And then 4 plus 1, well, that's just 5. And you'll see we got the same answer as when we did it using algebra tiles. Okay, let's do another one. Again, in example 2, you can see here this is subtraction. I know it's subtraction because that's a big old subtraction sign between my two polynomials. So I need to use subtraction there. Okay, in order to do that, I'm going to distribute my negative. I'm going to distribute the negative 1, distribute the subtraction, however you want to think about it. So I have negative 2x to the 4th minus 3x plus 9. So the first one does not change. Negative 1 times negative x squared is a positive x squared. Negative 1 times a positive 12x is a negative 12x. Okay? So I've distributed my negative, which changes all the signs. That's what multiplying by a negative 1 will do. Now I need to combine my like terms. I'm going to do it with a highlighter again. I think that was probably helpful to some of you. Okay, so I've got a negative 2 to the negative 2x to the 4th. That's the only x to the 4th. Then I've got an x squared. Then I've got, oops, I didn't change my colors. Here we go. Let me try that again. Then I've got a negative 3x and a negative 12x. Those are like terms. And then I've got a plus 9. There's nothing like that one. Okay, so starting with the negative 2x to the 4th, that is just going to stay because there's nothing like it. Negative 3x and negative 12x. Signs are the same, so I add and keep the sign. Ooh, but I should do my... Darn it. I should do my x squareds first because it's bigger. It's a higher degree. And then negative 3x minus 12x, signs are the same. So I add and keep the sign. And then my plus 9, combining my like terms. Okay, let's do one more example together. Video's getting a little on the long side. And actually, let's do example 4 because I kind of messed up on my print. I didn't realize that it had flown over. So do that, fix that. That 7 should be up there. And we'll go ahead and do this problem while we're here. Okay, so again, I know it's subtraction because it has, sorry, that dog barking, barking. Okay, I know it's subtraction because of the big subtraction sign in the middle. That's how I know that I need to do subtraction. So I'm going to keep the first one the same. And then for the second one, I'm going to distribute the negative, which means I'm going to multiply everything by a negative 1. Distribute the subtraction if you want to think of it that way. So negative 1 times 5k squared is negative 5k squared. Negative 1 times 3k is negative 3k, so minus 3k. Negative 1 times negative 7 is a positive 7. You could write minus a negative 7. But then that's more confusing. Just write plus 7. Okay? Combining my like terms. 2k squared minus 5k squared. Signs are different, so I subtract and keep the sign of the larger. Negative k and negative 3k. So signs are the same, so I add and keep the sign. And then 3 plus 7 is 10. And that would be my final answer there. All right, so there's two other examples here, example 3 and example 5. I would like for you to work through those two. And then once everybody is done working through the examples on page 3 and 4, we'll go over those together and take a look at page 5.